This video is about memory being a kind of general term for any device that stores data. We're specifically going to be looking at main memory in this video, and we're going to be looking at permanent storage in a future video. But main memory is any memory device that's directly accessible by the CPU. And so this is one of the grey areas in computer science where it varies, people's definitions vary, but usually often it's considered to be RAM, ROM and cache. I mean, we're certainly going to be looking at those in this video, but not always, especially cache is often kind of a grey area. Registers aren't main memory. We talked about registers in the CPU video, but they're not main memory. But RAM, ROM and sometimes cache are. But usually when you say main memory, you're just referring to RAM, or memory on its own is often just referring to RAM. And certainly I often use that in the context. In a bit like if you say processor, you're kind of associating it with the CPU, even though you might be talking about a graphics card processor, for example. So it's kind of like that. Memory is a bit of a vague term sometimes. But we have two types of memory, certainly. We have volatile memory, which is memory that loses its data when power is lost. And actually quite a lot of memories like this. You might not appreciate that without having learnt about it, but RAM is volatile, so is cache. Whereas non-volatile memory keeps its data when power is lost. ROM is non-volatile, a hard disk is non-volatile, anything you want to actually permanently keep your data on is non-volatile. Volatile memory is faster than non-volatile memory though. And the term memory tends to imply volatility, although ROM, which stands for read-only memory, is non-volatile. And storage is technically a subcategory of memory, but that usually implies non-volatility. So again, a bit of a grey area in computer science, I'm afraid. It's just how it is, but storage generally, and I think in real life, just kind of implies a very kind of steady, persistent, non-volatile, in this case, connotation, as memory tends to mean volatility. And main memory, to confuse things more, is also sometimes called primary storage. We'll be looking at secondary storage in a future video, which is also non-volatile. Anyway, let's talk about some of these memory technologies. First of all, we have RAM, which comes in sticks. It plugs into your motherboard. You might have a couple of sticks of RAM in your computer. We're talking about 4 gigabytes, 8 gigabytes, 16 gigabytes, so in the region of gigabytes in terms of capacity. And RAM stands for Random Access Memory. This name comes about because reading data from RAM takes roughly the same time regardless of where it's actually physically stored on the RAM. And that might seem somewhat obvious, but actually for some memory or for some storage, it really does matter where you've actually physically stored it. So on a hard disk, if you've stored it on the circumference of the disk, it actually makes a slight difference in reading time. So that's where random access memory, that's where the name comes from. And RAM is compared to persistent storage like a hard disk. It's very quick. It's not as quick as cache or registers, certainly not. But its function is to store a copy of open programs and operating system data. So anything currently open is loaded into RAM. So when you open a program, it's effectively the data for it is being copied over from where it's stored in your hard disk, usually, and moved over to RAM while you're using it, because it's much faster and it's directly accessible by the CPU. So anything currently in use is stored in the RAM, and this is why it's not really important for it to be non-volatile. Sure, when you turn your computer off mid Word document, it's annoying because you lose your progress, but it's the speed makes a big difference here. So to emphasise, you lose the data when the power is turned off, so it's volatile. The next memory is ROM, which stands for read-only memory. Make sure you learn what these abbreviations stand for. And ROM comes in the form of a chip that usually is on the motherboard. You'll miss it if you don't know what you're looking for, whereas RAM is very obvious on a motherboard if you've ever opened up a computer. So the name gives away what ROM is all about. It can only be read, so once it's programmed for the first time, the data can't be changed. And this is a very definitive statement. As always, as a caveat, there are some types of ROM that can be changed slowly or with difficulty, but as a general user, you can't just go in and change the data that's stored on ROM, and you wouldn't want to anyway, because it's used in very small amounts to store essential programs, like those needed to be run in order to boot the computer up. These are called bootstrapping programs, by the way, like BIOS. And as I mentioned, the RAM, to execute an instruction, needs to be copied into the RAM. And so the operating system is not the first program that gets run when you start your computer up. The program that gets run first is a program that copies across the instructions, the OS instructions from the memory into the RAM. And this is often stored on a BIOS chip, also on a BIOS, on a piece of ROM. So they tend to store firmware, which is a type of software which is very closely linked to hardware. It helps hardware to work, and it doesn't need to be changed, which is why it fits for purpose. So this is very much non-volatile. Data is retained when power is lost. Otherwise, that would defeat the whole point, because you would never be able to get your essential program. It should be said that actually ROM is mostly replaced by flash storage, which is also non-volatile, but ROM is still used in some cases. Cache is a type of memory that stores copies of frequently used data. So, this is because cache is much faster than RAM. I know I said a minute ago that RAM was fast, and it is in comparison to slower storage, but cache is faster than RAM, though it has a much lower capacity. For a CPU cache, you might have megabytes. It's in that region. It's not gigabytes like you would have in RAM. You have maybe megabytes of cache, CPU cache that is. And so, CPU cache sits in between the processor, the CPU, and the RAM. And whenever data is being fetched, it will check the cache to see if the data it was looking for is in there before going to the RAM. If it is in the cache, it will just return it. If it's not in the cache, it will then go on to look in the RAM as well. And so it makes sense to store frequently accessed data in your cache, because the more frequently accessed it is, the more often it's going to get found in the cache, so the benefit is felt more often. If you store data in the cache that is never really going to get accessed, then the benefit is not going to be felt, because it's never going to make any difference. In fact, it's going to slow the system down, because it has to check the cache anyway before going on to look in the RAM. So this is why you would store frequently used data in the cache. And we're talking data that gets used all the time, or even in modern processors, data that is kind of predicted that it's going to use soon. So cache can be very efficient if it's used properly. You also have caches in other contexts, not just in the CPU. You can have it in your web browser and in just storage devices. So for example, in your web browser, your home page is likely to get accessed all the time. Maybe Twitter, Facebook, you access all the time. The browser might have a cache that stores that web page, so it's loaded a lot faster. You'll notice some websites are loaded faster than others, and part of that might be down to the cache that's getting used. I haven't got it on my slide, but cache is volatile, so it's the same as RAM. When you cut the power, all the data gets lost. Let's have a quick look at a more visual way of recapping some of what we've looked at so far. Often memory is displayed as a pyramid, because as you increase the speed, the size and the capacity goes down. So registers aren't a type of main memory, but they exist on the CPU, as we've talked about. And these might be 32 bits wide, 64 bits wide. It's very small and very quick. These are the fastest type of memory in the computer. You then have cache, which might be kilobytes if it's L1 cache, or like 100 megabytes maybe if it's L3 cache. And this is slower relative to registers, but still fast in the general scheme of things, and is, I guess, relatively small. Then you have RAM, which is maybe you might have 8 gigabytes of RAM in your computer, so it's in the realm of gigabytes. And this is fast compared to the storage we'll look at in future videos, but is slower than the other two.